Today the law that we're looking at is the law of sines. And if you find your formula page, you will see that the law of sines is also given to you, just like the law of cosines. It is down on the left-hand side a little bit, about midway down. And it says side A over the sine of angle A equals side B over the sine of angle B equals side C over the sine of C. So they're showing you that the side to the sine of the angle across from it is in proportion to any other side and the sine of the angle across from it. We don't usually have three though, so we show it to you with just the two. We certainly could say side C, if we have that, is to the sine of C as any other side B maybe, over the sine of B. If your triangle has M's and N's and P's in it, then side M is to the sine of M, as side N is to the sine of N. So again, it doesn't matter what letters are in your triangle, this proportion will be true for every triangle. So a hint as we're doing these, and when we get a little farther on, we'll start to mix up problems, and you will have to determine whether you use the law of sines or the law of cosines from yesterday. So if it helps you, you can check out if you're given angle, side, angle, you'll use the law of sines to find the other side across from this angle. And if you have angle, angle, side in that order, then you can find the other side as well. Okay, the side across from the angle. So let's try some of these. And we'll always draw a picture. First one says in triangle ABC, if side A equals 9, remember that's the side across from angle A, and the measure of angle A is pi over 3, I'm going to use 60 degrees there, and the measure of angle B is pi over 4, so that's 45 degrees, angle B, 45 degrees. Then find the exact, so watch out for a radical answer, exact value of side B in simplest form. So what I do when I'm looking at these is if I have a matchup of a side across from an angle and a side across from an angle, I sort of look for that crisscross in my triangle. If I have that, then I know I'm using the law of sines. So let's set this up. Side A is to the sine of angle A, as side B is to the sine of angle B. Side A is 9. Sine of angle A is 60 degrees. Side B is what we're looking for. And the sine of 45 goes below. Now these are chart values, so I'm going to make sure I put them in as radicals because we wanted the exact value. I'm also going to, in this step, I'm going to cross multiply. So we're going to cross over 9 sine of 45 equals B times the sine of 60. And that's 9 times, do you know the sine of 45? Equal 2 over 2. Sine of 60. 3 over 2. And then to solve this for B alone, I would be multiplying both sides by 2 over radical 3. And here, 2 over radical 3. So before I multiply, I can reduce a top and a bottom. And I have 9 times radical 2 all over radical 3, which now I will rationalize. Gets a few more steps here. This then gives us 9 radical 6 on top over 3 in the denominator, and 3 goes into 9 3 times. So 3 radical 6 is that answer. All right, let's see what we have in the next example. Triangle DEF. The measure of angle D is 56 degrees. The measure of angle E is 44 degrees. And side D is 17.3. Find side E to the nearest tenth. So we're looking for this. We have a side across from an angle, and we're looking for a side across from an angle. So there's our crisscross. So we know side E is to the sine of angle E, as side, D is to the sine of angle D. Let's substitute in what we have. We need side E, that's to the sine of 44 degrees, and side D is to the sine of 56 degrees. Let's cross multiply, and then we'll use our calculators. You might want to pause and see if you can do this one on your own now. Make sure you're in degree mode. Check your mode. You might have switched things up in the last chapter. So let's see. To find E, I'm going to have 17.3 times the sine of 44 degrees. And I would be dividing here by the sine of 56 degrees. I'm just going to show all my work, and I'm going to type it all into my calculator. So E will equal, grab my calculator, 17.3 times the sine of 44. I'm going to hit enter. I'm going to check my mode real quick here. Whoops. Okay, let me do that again. 17.3 times the sine of 44. I was in radian mode. Equals, and then divided by the sine of 56. Calculator's misbehaving. All right, so what we get is 14.495832 by 3. Once you write all that out, take a look at what you're supposed to round to. We want it to the tenths place, so this 9 brings it up 1. So 14.5. There we go. These aren't too bad. Hope you agree. Let's extend this page a bit and look at the next one. So, word problem. The length of one side of the equal sides of an isosceles triangle measures 25.8. So let's sketch an isosceles triangle. And we know we have 25.8 for the 2 legs. And each base angle measures 53 degrees. Okay. Part A, find the measure of the base of the triangle to the nearest tenth. So they'd like us to find this base down here. So let's see, we need a side across from an angle, side across from an angle. I definitely have side across from an angle, but for this side I don't have this angle. So the first thing we need to do is find this angle up here at the top, the vertex angle. And we know that the angles of a triangle should add up to 180. So we have 106 degrees so far. And so from 180, there's 74 degrees left for this vertex angle. There we go, 74 degrees up there. Now I have my side angle pair that I need. I will know that x to the sine of 74 degrees will equal 25.8 to the sine of 53 degrees, right? Yeah, 53 degrees. Okay. 25.8 is to the sine of 53, as x is to the sine of 74. So what we'll be doing each time here is cross-multiplying and dividing over to get the variable alone every time. Pause, try it on your own. We've got x equals, grab our calculator, 25.8 times the sine of 74, and I hit enter, divided by the sine of 53, and check all those numbers, and I have a different number than is on my paper. Let me try that again. 25.8 times the sine of 74 divided by the sine of 53. That's better. And it shows 31.05365519 to the nearest tenth. Always check that rounding when you're finished to this part, to the nearest tenths. This 5 brings it up 1. And 31.1 inches. Part 2 of the problem says find the perimeter of the triangle to the nearest inch. All right, perimeter means to add all the sides. So let's do that. We've got our 25.8 plus 25.8 plus 31.1. Pretty easy problem, but just to have you thinking about all the different things they could ask you. 25.8 plus 25.8 plus 31.1 gives us 82.7. I'd be happy with that, but the directions say to the nearest inch. So the 7 brings it up to 83. Perimeter of this rectangle is 83 inches. All right, so law of sines. Let's do a few more problems together. Okay, on a playground, the 10-foot ladder to the top of the slide, just want to see my time here, makes an angle of 48 degrees with the ground. So we've got this kind of triangle here. I'm just going to duplicate it out here. So my 10-foot ladder, there's the ladder, makes an angle of 48 degrees with the ground. There's my 48 degrees. The slide makes an angle of 32 degrees with the ground. That's over here. Of course, this is our ground. How long is the slide to the nearest tenth? So the first question is to find the length of the slide. So, do I have angle across from side, angle across from a side I need? Yep. Law of sines here. X is to the sine of 48 degrees, as 10 is to the sine of 32 degrees. Let's cross multiply and divide and solve. X times the sine of 32 equals 10 times the sine of 48. That one. We're going to divide by the sine of 32. And get the length of the slide. Grab your calculator. 10 times the sine of 48 divided by the sine of 32. gives us a slide with a length of 14.02373674. We want it to the nearest tenth of a foot. So 14, that 2 doesn't bring it up. 14.0 is the length of the slide. Part B. What is the distance from the foot of the ladder to the foot of the slide to the nearest tenth? So now they want a different part of this triangle. I'm going to label it N. They'd like the distance from the bottom of the ladder to the bottom of the slide. So this side is across from this angle up here. Do we know that angle up here? Well, we have to use the other two angles. They add up to 80 degrees to find that we have how much left in the triangle. From 180 degree total, we'd have 100 degrees for that last angle. So now I know I can find side N. N is to the sine of 100 as, and let's use the original pair that was given, 10 is to the sine of 32. Cross multiply, divide, same old, same old. Always think about pausing when you want to try a problem on your own. It's just very smart to know that you can do it on your own. Grab your calculator. 10 times the sine of 100 degrees divided by the sine of 32 degrees. And it looks like we have 18.5841091. And to the nearest, let's check that rounding, tenth. Nearest tenth, the 8 makes it go up 1, 18.6. And there we go. Okay, last couple questions here, and we are finished. Might just set them up and have you do them. In triangle dog, angle D is 46 degrees. The measure of angle O is 76 degrees. And side O is 362. Find side G, G, to the nearest tenth. So pay attention to what they're giving you. Here's an angle across from a side. And the side they want is across from angle G. So the first thing we need to do is find angle G. Take the other two angles. Let's see what we have. We have 122. So how much is left from 180? We have 58 degrees left. So this angle is 58 degrees. Set up the law of sines. G is to the sine of 58. As given set, side 362 is to the sine of angle that measures 76. All right, you go ahead and give that a try. The answer, when you're done, side G is 316.4. You should be doing the cross multiplying and dividing. Make sure you can get that. And our last example is a word problem. And the picture is already drawn for you here. Let's take a look at what they're asking us to do. Let me move this out of the way so I can extend the page. Okay. Find the distance JM across a river, or to find the distance JM across a river. Doris found that the length of KL is 100 meters. Angle JLK is 38 degrees. and angle JKM is 41 degrees. What is the width of the river to the nearest meter? So this is a double triangle question. There's actually lots of triangles in here. This type of question, being a double triangle, typically takes 2 steps. So you want to pay attention when we're going across the river. We've got a 90-degree angle here. So we actually have some right angles, and remember that we can use SOHCAHTOA, just simple ratios if we have a right triangle. But in this triangle out here, I do not have a right triangle, so I'm going to have to think about that one a little more and probably use, in this case, the law of sines. So if I know that this angle out here is 41, then I can figure out this angle in here because it's a supplement. It's going to be 139 degrees. And then if I know this is 139 and this is 38, in this skinny triangle out here, I can find this upper angle. So then I'll have all of the angles. And that upper angle is going to be 139 degrees, 38 degrees. We've used up 177 degrees, so this skinny angle is only 3 degrees. Okay. Then in this big triangle, I'm going to recommend that you always find this shared side between that outer skinny triangle and the right triangle that's over here. Because if we know n, that's the hypotenuse of the right triangle. So let's set up. Let's make sure we have what we need. We have an angle of 3 degrees across from a side of 100. And we have the side we want, n, across from an angle of 38 degrees. So we're going to set up our first proportion as 100 is to the sine of 3, as n is to the sine of 38. So let's go find the shared side, and we're not allowed to round it. Not allowed to round it because it's not our final answer. Sine of 3, sine of 3. All right, so to find this shared middle side, n, we're going to do 100 times the sine of 38 divided by the sine of 3 degrees. Oops. I've got 117 point, oh, I'm sorry, not 117, 1,176.364243. So that's this side, n. Not our answer. Our answer needs to be the distance across the river. So now that I know that side, let me change up my highlighter here. I got a lot going on in this picture. Now I'm going to focus on this triangle, my right triangle. And I know this angle down here is 41. I know that my hypotenuse is 1,176.3642 blah. And I know that I need the opposite side. So I'm simply going to say, using SOHCAHTOA, the sine of angle 41 degrees should be its opposite over my hypotenuse. So the sine of 41 degrees equals x over 1,176.36424.3. And we're going to cross multiply. So x equals the sine of 41 times that big number. And we're done. Sine of 41, enter, times 1176.3644243. And the distance across the river, 771.76438828. And we wanted to round to the nearest meter. Excellent. So So